One of the techniques we can look at is called the function point analysis. Now, this technique has evolved to become what they call a multi-point technique that's used to help estimate the complexity, especially for large applications. The results of this is to measure the size of the information system based on what type of input we're going to put in, what type of output we're expecting from this system or this program, the types of files that we're using, the interfaces used by the users, the GUIs, the graphical interfaces, and the types of inquiries they might make. It is at least, you could say, an indirect measure of the software size. Now, function points, what we call FPs, make up the FPA, the function point analysis. There are 5 FP count values that we define. And, of course, that kind of goes into what we use to make the estimation using this function point analysis. That is, the function points we look at are the number of user inputs, the number of user outputs, the number of user inquiries, again, the types of files, and the external interfaces, whether they're command line based or GUI based, or if it's programmatically based and connected to yet another program. Now, there is a mathematical equation that can compute the complexity of the function point, along with rating factors to help you derive the size of the software application. Now, the good news is you're not going to be tested on that mathematical equation, just to be able to make sure you're familiar with the use of function points. It's very important to be able to estimate the amount of effort that it's going to take to carry out each task. And it's from those efforts that you're going to be able to develop budgets for cost, because you're going to know what each of those tasks are. Now, what are you going to look for? Obviously, the personnel hours, because we have to pay them their salary or hourly wages. The machine hours of the equipment that they're using. And any other external costs that might be involved, like maybe there's specialized software they need to help in accomplishing a task. So we have the purchase of the software and licensing. Maybe they bring outside consultants or training them in the use of specialized software. So all of those kind of go in as the external costs. Now, the biggest part of this is probably the first two, the personnel and machine hours. Once you have those two, you can tabulate those for each task. You then basically multiply that value by the appropriate hourly rate that you would charge for the personnel and machine hours. The size of the software also affects the estimation of the cost. Now, there's a lot of automated techniques we can use to assist in the estimation and break the application down into basically the following components so that we get kind of the idea of what each part of this is going to be for our estimation. So what are the components for software, for the application? Well, you got the source code. That's, those lines of code, the thing we talked about, what has to be typed out and created. The execution time. The main storage of the information, the data storage that might be supplying the actual application, the cost of the target machine that we're going to be developing this thing on, and of course, whatever we need for an appropriate security environment. Beyond the costs, we also have to go and establish the scheduling. Now, the scheduling is a sequential relationship among tasks that have to be arranged according to things like the earliest start date, which is something we'd assign to a sequential relationship among the tasks, or the performance of tasks in parallel. The latest expected finish date is something we would consider as the estimate of hours as determined by the budget and the availability of resources. Now, your schedule can be represented by things like a Gantt chart or something that's called the critical path method, or the program evaluation review technique. One of the analysis techniques we can use, we call the critical path methodology. Now, we know that all project schedules will have what we call a critical path. Now, the paths, if you can imagine this like this little tree, will be represented graphically as a network, where the activities are going to be shown as branches, and those branches connect to little nodes, which would come before or after. So you can think like a little tree, right? We start with the beginning, and then we branch out to these different activities, and from those activities we branch to other little activities, and what we do is we look at that, and that's kind of the path that our development project will take. Now, the term of a path, as I've hopefully just described, is a path to the network. Is any successive activities that go from start to end. Now, the critical path is what is the longest path through that network. And that would be, again, looking at the sequence of activities where the total sum of time for that sequence would be longer than any other path in the network. And technically, if you think about that, that means that in the overall project, while we might be doing some things concurrently, the longest path would be the one that would be what kind of dictates the amount of time it would take to finish this particular program. Another thing we can do for the estimations is to use a Gantt chart. Now, these are designed to help you aid in the scheduling of activities that are needed for a project. Now, the chart should show when an activity should begin and when it should end, and it would be kind of along a timeline. The chart can also represent concurrent activities. So if you can imagine this chart, and the bottom axis, so the one that goes horizontally, would be the start and the stop time, and the top axis would represent all of the different activities. You may have some activities that are running concurrently at the same time in this representation. It also, because it's a start time, stop time for each activity in the overall project. And when that one activity stops, maybe then the next activity begins. So you also see some of those sequential activities. PERT stands for the Program Evaluation Review Technique. And it is a CPM type of technique that uses 3 different estimates of each activity duration instead of having a single value. Now, we use PERT when there's a chance in the actual development project that you have uncertainty about the actual duration of the project. So to be able to find a task completion, basically we have 3 estimates that we would use for each of the activities. And these estimates could be from the most optimistic to pessimistic to worst case scenario. Now, once you get those 3 different time sets, those time estimates can be reduced to a single number and then applied to the CPM.